Hey guys, welcome back to my channel. So today we are going to discuss trapping rainwater, again a Leetcode problem. So given n non-negative integers representing an elevation map, so this is the elevation map which you see in black, where the width of each bar is 1. Compute how much water it can trap after raining. Okay, so this int array is the elevation map. As you can see, this is 0, 1, 0, 2, 1, so on. So the blue highlighted portion indicates the trapped water, and that is what we have to return back. So one thing that we have to understand is water, being a fluid, has to be contained. So it needs to have boundaries either on the left side and the right side. And as you can see that there's no water stored here because it has no boundary. And if no boundary is there, then it might spill on either side. Okay, so that is why wherever we have contained water, you see there will be boundaries. Okay, that is one point to consider. And the other point is regarding the level of water. So you see these two boundaries, the left hand side and the right hand side ones, and you will notice that the level of water is determined by the lowest boundary. Okay, so that is how we are going to resolve it. We will kind of build an intuition around like how to resolve this. So let me start coding and I'll explain it on the way. So we will have an array, and I need to determine my left boundary and my right boundary. Okay, so and it has to be maximum because we don't know how much water can be contained. So for the first part, we will try to calculate which is the highest boundary on our left hand side and on our right hand side. Okay, so for that, left is equals to, we'll initialize it with I. Okay, and then we will run an array from the left hand side to our present index, that is 1, right? So j will run from 0 to j is less than I. So left will have the maximum of whatever we have on left, and height or the present index. Okay, so we get whatever boundary we have on, whatever maximum boundary we have on the left side. Great. Now we need to do a similar thing for the right side. Let's just paste it. So j the boundary what we have on the right side will go beyond our index, right? So that is why it starts with I plus 1 and is greater or it will be less than n, right? So right will be max of right. Great. And we have our variable to calculate the amount of trapped water. So what basically would happen here is we have a particular height of the boundaries, right? For example, this particular portion, we have to calculate this amount of water, and the left boundary which it has is 2, right? But the amount of water is 1, like, and minus the elevation, right? Because we don't need to consider the elevation, we are just considerate about the amount of water present in this section. So whatever is the height we are getting for that particular index, and we'll minus the particular elevation, right? And we will get this value. So that is exactly what we are going to do. We are going to pick the minimum of both the boundaries, because of the level of water is determined by the lowest boundary. So left, right, and minus the height of the particular index, and we have to return answer. Okay. What did I do? Okay. Okay, so this got accepted, but I'm not going to run this because this is n square solution. We have our loop and then we have a nested loop, and we can come up with something better, right? So this is our brute force. It's good to understand the brute force, and like, I mean, we should understand the brute force, but let's move to a more optimized solution now. Okay. So for our optimized solution, we will consider this particular array just to understand what we are going to do here. So we need to get whatever boundary which is highest on the left side and on the right side, right? So for that, we will do some kind of pre-processing in the array. We will maintain a right array and a left array, okay? And we are going to, for the left, we are going to traverse from the front and do a comparison between two indexes and move forward, like determining which is the highest. So out of 4 and 2, obviously 4 is the highest, right? So 4, 4, again 4. Then there is a comparison between 4 and 3. So 4 is the highest. Again 4 and 2, 4 is the highest. And then we have 4 and 5. So 5 is the highest, right? Now for the right array. Right array, we will be standing from the starting from the end of the array. So let's just go there, and we'll make a comparison between the last element and the second last. Okay, so this will be 5, 5, 5 compared with 2, obviously we'll get 5, 5 compared with 3, we will get another 5. Okay, let me just pull it here. Okay, so 5 compared with 3 also we get a 5, and then 5 compared with 0 obviously 5, then 5 compared with 2 will be a 5, and 5 compared with 4 will be a 5, right? So for this, what we are getting is just 5. Let me just align it a bit. Okay, and now we need to see that which this is the highest you are getting at a particular index in the left hand side and in the right hand side. So out of the two, how we were doing it in brute force, we will pick the lowest. So out of this, 4 is going to be the lowest, and that gets picked. And if that is higher than the present elevation, then we are just going to deduct it and add that amount of trapped water to our answer. Okay, you will understand it better once we code. So we will be maintaining pre-processed arrays, right? So int left is equals to new okay. So for our processing, I will start with 1 and I will go up till n plus plus. So we need to assign an initial value to the left array. So left of 0 is height of 0. Okay, now left of I is equals to math dot max left of I minus 1, because we want to make a comparison between the very first one and the second one, right? And height present at I. Okay, now we need to do for the right. So for the right, we will start with the end of the array, so n minus 1, and the height present at n minus 1 will be assigned to right, and we will start with n minus 2 because n minus 1 has already been assigned, and this will let's do 0. This will go up to minus minus right and right. I right won't be I minus 1, but it will be I plus 1. Okay, because we are fetching for the right part. And if you compute what we have here, the value of I out here, you will see that we are making a comparison between I minus 1 and I minus 2, right? So whatever we have in the extreme end and the one next to it, just a comparison between the two, like as we did in the example. And then we have to traverse. So these are different loops, right? So we will get O of n solution for this, not any nested values, and I, or nested loop, sorry, will go till n minus 1 and I plus 1. So we will be calculating the minimum. So again, if minimum is greater than height present at that particular index, we have a variable answer, and we are going to do a min minus height of I. Okay, so we are returning answer. I think everything is fine. Let's just run this. 13 and 19. Okay, and hoping you understood this question, because this is a very important question and has been asked like a number of times. So keep practicing, and thank you so much for watching this.